a bit of a new way of doing our
That's
sessions.
right. Yeah, if I say a few words about that, so we, as a XTechnology, we decided to introduce a new format, and the reason is quite uh, straightforward. We are a small team, and we don't have that much resources to do um, the events of some certain quality often enough. So we decided, okay, but we are doing some work anyways on our self development, yeah, weekly or daily or whatever. So why can't we basically do the same but with our followers? So that's kind of the first session of that type where we gonna challenge ourselves with some tasks that we wanna improve improve our coding skills or whatever, or data science skills. I don't know, Igor, what we want to improve today.
I don't know. I suppose I would like to improve my coding and not stressing out skills
Mhm.
during the interview. Yeah, because honestly, I've never been on an interview with this online coding, LeetCode style stuff. Yeah, I'm kind of an old guy, but I've never experienced that. So it's always nice to start. And yeah, I also don't have a software engineering background. That's why today it's going to be fun for you, I suppose, not for me. Because yeah, I'm a data scientist, but coming from an analytics background, and I don't have this knowledge of algorithms, data structures, you name it.
Mhm.
So it's going to be fun today, I suppose.
I'm sure you're right with level on this, but let's see. Let's
Yeah, well, I don't know. I think it's nothing more to say. Here is a LeetCode screen. A small plan what we're gonna do today. So I suppose we should keep it maybe not more than an hour, probably even less, to make it not super boring to watch. And I suppose we can, I can randomly pick a couple of medium tasks. Let's filter them. Yeah, so as you see, I've already tried a bit, actually two. Well, I fulfilled two of them. Maybe I tried a bit more. I don't remember exactly. And I suppose I could start doing one of them. And if I'm not doing any good, you, Alex, could help me or just laugh at me. And if I'm doing no good for maybe 20 minutes, we could just drop the task and go to the next one. That's what I think.
Yeah, I'm sure it will be fine, Igor. So don't worry. And if we're stuck, we're stuck together because you think I. Why do you think I managed to solve this? It's no way, I would say.
I
But
don't know. I don't know.
let's see.
So yeah, so there is this level of acceptance, and I'm a bit yeah, I'm a bit afraid of some middle level assignments which have this level of 16%.
Acceptance, maybe is good to explain it for our
Mm-hmm.
listeners as well. Acceptance is what does this mean?
I honestly I don't know exactly, but I suppose that it's kind of the proportion of people who succeeded in this task to the amount of people who tried. That will be
Like in
relative to me.
total or from the first run? Do you know? Is there a
Ah, yeah, that's a good question. I would say I would say in total because otherwise it would make no sense. Maybe, but maybe you're right. Maybe from the first submit, because yeah,
yeah?
if you when you go to every task, you can submit multiple times, and if you're not good, you can resubmit and so on.
Yeah. Yeah, it
So
sounds like
yeah,
in total, but let's.
yeah, sounds like in total, yeah. So I'm a bit worried about 17% or so. So I don't know. Let's just pick the random one. Yeah, 40% spiral. Yeah, I'm afraid of this number.
And
Merchant
also
rulers.
a question before we start, maybe I have a friend. I talked. He's preparing himself for a Facebook interview now, and
Mhm.
what the recruiter said to him, he sent an email with a, I think not a task, but like preparation strategy he could use or something like that. And basically, it has some coding tasks, if I understand correctly. Maybe it's not also only coding, but how I understood that it contains like 30 tasks for LeetCode or similar platform to solve. So is it something like that in your mind? Like the more you solve, the better you prepared for a Facebook interview or Meta interview?
Well, yeah, I suppose it works like this. Yeah, I mean, as I said, I also haven't ever tried it. I'm always like a bit afraid of this stuff that people say that they prepare for like half a year and do like 20 tasks a day every day for half a year, and then they prepared. So this is too scary for me. That's why I never tried. Yeah.
Right.
Yeah, I don't know. Like, I think it's time to start to do something.
Let's do that.
So yeah, I'm a bit afraid of what spiral metrics is. So maybe merge intervals. At least I know the word merge and the word intervals. So yeah, I will try to do everything in Python because I don't know any other language. So in LeetCode you can choose between different languages. So Python 3 it is. And yeah, so let's read it. Should I make it bigger or maybe yes, it makes sense to rearrange it. Probably like this. Yep. So what does it ask about? Given an array of intervals where intervals, the ith of the interval has these structures, so start and end, merge all overlapping interarrays, and return an array of the non-overlapping intervals that covers all the intervals in the. I'm already like lost when I read it, so I usually go to the example. So yeah, for example, as an input we have this array of 4 intervals, and the output will be. So explanation, since intervals 1, 3, and 2, 6 overlap, merge them into 1. Okay, so and return non-overlapping, cover all the intervals in the input, merge all overlapping. Okay, so we have to look at the input intervals, find them overlapping ones, merge them into 1, and return the result, as I understand. Okay. Well, nice. So yeah, there are some constraints that say to us that there are not more than 10,000 intervals. Yeah, also the length of interval is 2, and okay. Also, it doesn't say anything about if the intervals are sorted by the first element here, because in all the inputs it is sorted. Or does it say anything about it much? Because if it's not sorted, I suppose it will be a different task, right?
Yeah, very good thought. I think. I mean, sorted is first take my mind as well. So I think indeed maybe we should do sorting first, or you think we should suppose they're sorted now?
Yeah, I honestly don't know. I mean, it never says anywhere that they are sorted.
Yeah.
Just 2 examples.
Yeah.
So I mean, in Python it's very easy to sort, but you will lose a lot of computational
Yeah,
stuff.
but
So I don't know.
it doesn't have requirements over computational and performance metrics, right?
Yeah, I think it does. So for now it doesn't say it, but when you will submit your code, it will probably fail on some examples. But I don't know. Just for fun, I think it makes sense to start from the very stupid solution because I currently can't think of non-stupid ones. So maybe as a first step, we can just sort it and go from there. So
and how are you gonna sort it? What is your desired state of this array when it's sorted?
to sort by the first element of all the intervals.
Yeah.
So
and if there are 2 intervals and they're both starting from the first point, then how are you gonna put them into the result?
Yeah, then to sort by the second element. So ideally it would be something like this.
Right. I think it's a good thought.
Yeah. Honestly, I'm not sure if I do like this. I don't know how Python will sort it. We can of course cheat a bit and see. That's what I usually do. You know how I
Yeah,
code in
that's
Python.
fine.
I do like
You
this.
should be in JavaScript. In JavaScript, it's like a scientist way of solving.
Yeah. So that's how I started. So let's see input. Okay, yeah, it doesn't really do anything.
Maybe debugger has something.
Debugger, it's locked. You see.
And use
But
example test cases on the bottom. Yeah, whatever.
yeah, but we can do something like this. I don't know. So we can intervals hours. Yeah, that's how I waste time in the intro. Yeah, 3 1. Okay. 3, and here we put something like 2 4, and here 2 5. And just let's just see what the output will be. Yeah, okay. So by default it sorts in the way that we want. So by the first element and then by the second. So at least this will work. If the input is not sorted, then we have it sorted. Then we have to solve the task itself. So I don't know. For now, I cannot see anything besides just iterating through the whole array intervals, and do something. And by the way, so if we have 3 intervals overlapping, then we have to merge all of them, right? So all overlapping intervals. Yeah, I already don't like this task.
Now that sounds interesting to me.
Yeah.
Now
Okay.
I think yeah. You don't
Yeah,
need
yeah.
some specific logic. You can just do whatever is in your mind, and I think it's correct. Actually, you're going to do now.
I don't really know what I'm
Enumerate
doing.
makes it iterable, sort of, so you can go through the array here.
So yeah, in Python, enumerate adds this index element. So you have a list. If you will just enumerate through the list, it won't give you the index of the element. And here you will also have the index of the current element.
What do you think of modifying array in place? Is that something that you? What's your opinion about that? Correct. Yeah. To that task, corresponding to that task, I mean.
Yeah, we can.
Do you like it
can,
that way? Are there any obstacles or any drawbacks?
I'm just afraid if I will do it in place, I will overwrite something valuable. And then the answer will be not correct. But
yeah. To be honest, I prefer, as a programmer, I prefer to have a new storage for modified elements, anyways. So yeah, I think it's better to not think of additional memory or whatsoever. Specifically
like
with
that.
Python, because it's a scripting language, right?
Yeah.
That's good.
That's how I call myself a script writer, not a programmer. I write scripts. Yeah, so I usually create something like this. So this will be our output list, and here during the iterations, I do something and then append to this output empty list and then return it. But yeah, now we have to think what to do with this. So first of all, we somehow have to remember the current overlapped interval, I would say. So let's say the current element will be the interval, right? So the interval.
Is it the current or the one that is merged, actually, the one from output?
No, for now it's the current one, so we just enumerate through the sorted element. I suppose we can. Yeah, I'm not sure. I will just try. So I want to introduce something like current overlapped and make it empty for now. And then for every iteration, I will compare the interval with the current overlapped. And if some condition is okay, then I will add the current one to the overlapped. If you know what I mean. So for example, what would be the condition? So if interval. So what is that? So we have like 3 intervals. How we name them? Start 1 and 1.
I think it might be a good idea, like to have a separate function is overlap or something like that, and then you can move this logic in there. And,
Yeah. I agree. It would be nice to have it. So okay, def is overlap. I1, I2. Yeah, I'm not good at types, so I never do this. So what will be the, and yeah, we will say that they are always sorted. So the input intervals are already sorted. So we don't have to do it. Boom, boom, boom. And yeah, I'm just thinking. So yeah, it's. I feel that I need a piece of paper. So my brain just doesn't work. So first of all, if S2 is less or equal than E2, right? Then it means that they overlap. Is it the only? Yeah, I think that's the only case, right?
So you compare now the second interval.
Yeah, I mean.
2 and start
Yeah.
2 and end 2.
Yeah. S2. Yes, sorry. I meant that if. So the start of the second interval should be less than the end of the first one, right? So if less or equal 1, sorry, zeros, then they are overlapping. And then maybe we already return overlapped. Then we can create the return something like zeros. Oh, sorry, yeah, I have I1, I2. I2. So like the overlapped interval. Else, yeah, it's not a nice idea now. Yeah, that now I maybe didn't think that we don't need this function. Use overlap. Okay. Overlap. Return true. Return false. So I suppose.
So I1 0 is the beginning of the first element or the first interval, right? This one, yeah.
Yeah, you're right. I wrote not the correct one, so it should be like this. Yeah. So the beginning of the second one should be less or equal than the. Yeah, you're right. Thanks.
Okay.
Okay, so then let's try it. So if yeah, actually, if my interval is yeah, it's 0, so I suppose we can. Yeah, if the interval. So my current interval is the existing one. Then we do something like this. So we say. Yeah, so we have to somehow initialize it. Yeah, now it's not correctly initialized because the function will break. It's empty. But when we will initialize it correctly, then we will iterate through all the intervals and compare the current overlap with the iterated interval. If they do overlap, then we extend the current overlap. So that's what I want to do. So the new current overlap will be it will start from this element up to interval this. Yeah, I will rename the interval to current interval just not to be confused. So yeah, it is still, so we extend it, and if they are not overlapped, then it's time to write it to the output because it's already kind of fixed. So I suppose we can do something like this, and yeah, so if we can extend it, we extend it. So if they're overlapping, we still extend it. If they do not overlap, we write the previously extended one to the output, and then and then say that current overlapped, reassign it to this one that we didn't manage to add to the previously extended. Yeah, I understand that it's probably not understandable what I'm talking about.
No, it's good. It's good. So I ask some questions during that. What is line 9 then? Think of a case when several is included in the first one, in the previous one. Is there something in this expression that is not going according to what we want?
Is included. You mean that it's less, kind of? So
yeah, the end is less than the first one.
But I suppose it should be fixed here because we already sorted. Or yeah, because we already sorted, as you see. So our it should never be the case, if I understand correctly how this works.
You think so? 10 and then 2, 5, for example, and that will be our order, right?
Yeah, you're right. Yeah, that's right. Okay, yeah, that makes sense. 110, yeah.
So I suppose in your solution we can add something like no, it's overlapped. Should be good. But anyways, you solving it. Maybe I shouldn't interrupt you too much.
No, I think we can. Yeah, you go, please.
Yeah, maybe it's just max function would help you 9 for that.
Yeah, you're right. I was just thinking actually maybe to rename this is overlapped into something to merge or not, because for the case of 1, 2, 5, 10, we don't have to merge, right? Because it won't give us anything meaningful.
Yeah, I don't know. Yeah, it depends what logic you want to put there. You can. So I think in general it's a good idea to have a merge function, so we can think of that separately from our iteration process. And then we can decide what to do with it.
Yeah. Okay. Maybe what you're saying is a bit easier to do. So yeah, here instead of taking the right element of the second interval, we can say max of 2 of them. Sorry, it's auto formatting, not super nice. Maybe something like this. Probably it's a bit more visible. So max, yeah, so it will still use this function. So these two elements will say that yes, they are overlapped, and we will take the first element of the first one, so this one, and then the max of these two. Okay,
yeah.
Then,
And in this logic, it cannot be the other way around, right? Like, I mean, the first element, sorry, not the first element, the beginning of both intervals always in the correct order. So we cannot be in a situation when the beginning of a next interval is less than the beginning of the previous interval.
Yeah, but that's only because we did this.
think so. Yeah.
Yeah, but I'm a bit afraid that when we will try to submit it, it will fail because of this. But yeah, let's not think about it right now. Yeah. So what is left? We have to somehow initialize the first current overlapped. I'm thinking what is the best way to do it, and maybe we can just initialize it as the first element of the intervals. Pum, 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 pum.
Yeah. First of intervals sorted. Yeah.
Or maybe yeah. So yeah. Okay. I think it will be just the easiest. So zeros, and it won't prevent us. So we can still iterate through the first element because it won't harm us, right? Will it? So I'm just thinking of each case. So we have one element, for example. We initialized it as, so for example, it's 1, 5. We initialized it as 1, 5, and then we iterate through 1, 5, and they are overlapped. Oh, actually, they're not. No, yeah, they are overlapped because it's less than equal. And it will go through here. It will create the current overlapped. Yes. Okay, but then yeah, for this use case, we have to somehow maybe we have to do this after the iteration to kind of add the last element or not. No, wait. That won't work. I'm just thinking, so if you have only one element, it will go through here. It will say that yes, current overlap is extended, but then we have to somehow publish it to the output. So append it to the output. But we already won't do it because we will not go here as our enumeration will end. And so if you go to else, we definitely publish it. But what if our element was the last one? So yeah, because I think if I will just add it like this.
Yeah. I think it's a correct one. Yeah.
Yeah. So it will work if we had, like, for example, so for one element it will work.
So in your cycle, in your for loop here, basically you always merge to the current overlapped whatever can be merged, right? But you don't add it in the last iteration, never.
Yeah.
And that means that you should do it after the cycle once.
Yeah, but I'm just thinking. So, for example, for this case, let's say we have like this, and then we have like this, right? So then the first iteration, our output will be. So the first iteration, it will say that our extended element is 110. It will not add it. Then the next iteration, it will still keep it. It will not add it. The next iteration, it will still keep it and not add it.
Yeah, sounds good.
You're right. Yeah, you're right. So yeah, there is no case that we will write it up. Yeah, I just thought that in some cases we'll write it twice to the output, but it seems like not. Okay, so yeah. Yeah. Okay.
Yeah.
Put it here.
Looks good.
Yeah, let's just run code. Yeah, that's what I do always. At least.
We broken LeetCode. Oh.
Yeah. Is overlapped. Is not defined. Class solution. Yeah, now it's my perfect knowledge of object-oriented programming in Python.
Should be this. Should we use this dot is overlapped, or how it works in Python?
Yeah, I mean, what maybe I will do is can define the function in the function like this. Looks super ugly.
Python.
Yeah, Python. Okay, yeah. Sorry, I still don't remember how it should do it. Probably you're right. We can do like somehow say that it's from self like this. Yeah. Oh, maybe it does make sense to do it. Sorry. We can do this. Yeah, I'm just trying random things. You see. No. Okay. Okay. Yeah. I'm too stupid to solve it right now. I will just leave it as it's called. So within this function, we first define this additional function, and then we go for it with it. So it worked for a couple of test cases, as we saw. Accepted. Yeah. Let me see. Maybe it's not visible nicely. Okay, so yeah, and usually what I do now, I click submit, and let's see what happens now. I guess we will fail at some use cases because, oh, actually no, we didn't. That's super nice. So Alex, if you're still here and you can cheer it with me, it is super cool. Thanks for guiding me through it. That was our first solved task. Hooray! And it says that we did it faster than 78% of people, which is super weird because we used this interval sorted stuff. Oh. Okay, so I suppose we can say that we did it, and yeah, it's actually 10:30, so it took us maybe 25 or 27 minutes. It's a bit more than I expected. Not expected than I planned to spend on one task, but anyways. So yeah, so let's just go back to all the problems and pick the new one. Yeah, I should drink a bit. I'm too excited. Yeah, so excitement. Yeah, let's again pick medium ones. We know that we already know that we can do it together at least. And by the way, Alex, thanks for some tips. I would fail without them. Definitely.
No, you definitely would not. But congratulations, man! I prepared already. I had to celebrate it. Sorry, for a second.
Yeah, I got it. Yeah, you went to open the champagne bottle. So yeah.
Yeah.
Right. Maybe just go to random page number 5. Yeah, I suppose one more task will be enough because it's already going for quite some
Yeah,
time.
that's good. Yeah, good idea.
Yeah. Oh my long names. Quad 3, remove k digits. Rotate function. Rotate longest substring. With at least k repeating characters. Elimination game. I don't. Do you have some name which you like? Linked list random.
Yeah, looking at that sounds super cool here, but
guess number higher lower. Yeah, I don't know what it is. Let's see. Guess number higher or lower. Part 2.
other like data science small simple tasks that we can do in the next session, for example, like that. Or
I think there should be, yeah, because what I did experience, yes, a bit of live coding data science stuff. It's like easy from algorithmic perspective, but more about data analysis. But I didn't manage to find it. So on LeetCode and HackerRank, I didn't find it. Yeah, I should maybe try it
yeah,
later.
next time maybe we can have fun with something else. Yeah.
Yeah. Oh my God, I'm already like this is a graph.
Oh, really?
This is the wrong one, I think. Okay, so we are playing the guessing game. The game will will work as follows. Yeah, fork. I pick a number between 1 and n. You guess a number. If you guess the right, you win. If you guess the wrong, I will tell you whether you picked the higher or the lower, and we continue guessing. Okay, every time you guess a wrong number x, you will pay x. Wow, x dollars. If you run out of money, you lose the game. Oh my God. We could play it live. So, given a particular n, return the minimum amount of money you need to guarantee a win regardless of number you pick. Oh, wow. Okay, I pick a number between 1 and n. Yeah, it sounds fun, but to me it sounds really complicated now. So yeah, let's say if
binary search structure here.
Yeah.
So is that basically it's defined number. I mean, in a binary tree, which is sorted, you can search in a max logarithm and complexity. That's maximum, and the task is saying.
Yeah, that's the minimum amount of money you need to guarantee. But yeah, basically that's probably the worst case that you have to look at, right? Okay.
Or the best case.
Yeah, it depends on who you look at. Okay, so if I understand correctly, yeah, you have this this tree. So every time you go, you split on 2, and we are asked that what is the number to guarantee a win, and guaranteeing a win means that we are like a really bad player. So we guessed it. Okay, so if yeah, sorry, I'm jumping, but let's say we have 10 numbers, and I have to guess which number it is, and the worst scenario for me as a guesser will be to do. I said so. Yeah, it's always binary search, so it's powers of 2. Yeah, again, sorry, I have to draw it somehow. 1, 2, 3, 4, 5, 6, 7, 8. Just to keep it at powers of 10 of 2. I mean, so let's say the first time I picked the wrong one. So let's say I said 8, but it's not 8. No, wait, it's not that easy. Okay. So if I'm a clever player, I should use this division by 2, right? So if I know that the max is n, I should ask about n divided by 2. So
would it be a good idea to look at the examples, because I don't fully understand how this whole game works? Like, what that means that you give me this and I give you that, and what money doing that?
Yeah. Okay. So let's say we look at the example. We have 10 numbers, and the winning stretch is also very interesting. Yeah, guess 7. So we have to guess 7. If this is a number, your total is 0. Otherwise, you pay 7. Okay. Yeah. So if your number is higher, the range is guess 9. My number is correct, and otherwise you pay 1. Oh my god! The worst case in all scenarios is that you pay total. If your number is high, it might be 2. Guess 2. Hence, you only need 16 to guarantee you win. There's only one. Yeah, I'm just thinking.
This part.
Sorry.
And no worries. We're gonna cut this part anyways. Sorry.
No, maybe not. Maybe yes. Maybe
no,
maybe
not.
We should. Yeah. I'm just thinking. Yeah. So, what is the strategy? What should be a strategy to win this game? Because yeah, you have to guarantee win, but spend less.
So the input is always a range from 1 to n, right? Is that and then the idea is that you should select some strategy of giving numbers from this range and okay,
yeah. I mean, if the strategy will be to solve it faster in less steps, right? You will always do a binary search, right?
So
split it.
I think so.
Yeah, but I'm not sure if it will be the least expensive. That's what I.
And the least expensive would be start from the beginning, or from the smallest one, right? And then so you start with a lower number, and then maybe actually it's a good question.
But then.
I think in general it should be like that. In general, it would be whatever. Please continue.
So return the minimum amount of money you need to guarantee a win. So let's say if I do let's say I'm just doing a binary search. The first step, I would say 5. So I give away $5, and let's say I was wrong, and I have only 5. Let's say I was wrong, and I have 6, 7, 8, 9, 10 because the answer is somewhere here. Then I'd say 8, and then I again was wrong, and I have, let's say, I'm just trying to guess to get the worst case, always keeping the worst, and then I say 9, and then again I was wrong, and it's 10. So now it's correct. Now I win.
So I think I know the solution. Let me tell you.
Yeah.
So we know that binary search is kind of guarantees us the number of iteration, the maximum amount of iteration we need to find the number, right? That's log n. We kind of know that.
Yeah.
And then what we can do, we can from that we can iterate from all the numbers from 1 to log n, and that would be our minimum. That would be our minimum amount to guarantee it, I think. So because basically we need to do these iterations in a worst case scenario anyways, and these iterations we can do and then we need to choose what would be our numbers in these scenarios. I thought I knew it, but
yeah,
it seems that
no, I'm just thinking right now. So now to 16. So the winning strategy is as follows: guess 110,
so,
guess 7. Yeah, you go.
No, again.
16. This is my number. You talk about 7. Otherwise, you pay 9. This number is higher. I just don't think that their example is correct.
Is it for specific particular number or for any number? It says.
It's a good question actually. So guess a number. Given a particular n, return the minimum amount of money you need to guarantee a win, regardless of what number I pick here. Because because the first example is for n equals 10, and they say 16. But here is an example where I need 22, if I'm not wrong. Oh yeah, although it's not the minimum, of course. Yeah. But even with their example, so let's say let's go with their example. So they say 7, and then the answer is in the 8, 9, 10, and then I say okay, yeah, then I say 9, and it's I already know the answer, right? Yeah, that's true. Actually, will it always work like this? That I leave 3 elements to the right? But it will be too stupid. Just you know what I mean? So
3
if you
in 10, if you give an n is 10, then
like I don't know, n minus 3.
I'm still trying to understand
Plus
the
minus
task
1. Yeah. Because that is always the solution, right? So no matter how many. No. Is it always a solution? Sorry, I'm just because what if it's lower? What if it's lower? And then 1, 2, 3, 4, 5, 6. You do the sum of this. So you pick again. I don't know, 3. So yeah, that's the sum of the rest will be always less, right? And say 5. and you win. So 3 plus 5, 8. 8 plus 7 is 15. It's less. Okay, will it always be the case?
It's cool stuff. It's not the
Yeah.
simplest, I think.
It's not what?
Not a super simple task.
Yeah, I completely don't think it's simple. I just don't know. Like I am tempted to try this answer, but it will be too stupid if it will work. Because I don't know if we have much more 11, yeah, blah 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 50. So if we say 47,
So
then
it's a matter of balancing your tree. Like you have weights of your binary tree, and basically what they do, indeed, they kind of balance it. So on the left, you have the lowest weights, and then the amount of steps there with the price that you need to pay for each step is kind of in balance of what you have in right. You have less steps there, but they cost more. That is the idea, I think, in here. Yeah.
Yeah.
So it should, but it's not. I'm pretty sure it's not n minus 3 plus n minus 1. But the idea is exactly that. So you need to like structure on the right less steps, on the left is more steps. You need somehow to think of how should we make this balance correctly.
Yeah, you're right. I don't know like how to try, because so if I will always do n minus 3, let's say 47, right? So if the right answer is on the left part, so it's from 1 to 46, I will always spend less than 47 to find it, right? Because I will start from half of 46, then from half of what is half of 46. Yeah, and then it cannot be more than 47, right?
It can be.
Can be?
I think. Yeah. The sum would be n plus 1.
Yeah, but I summarize them, but I always add less than a half of the previous. So it's kind of the limit of it will be 47, no? Because let's say it's from now 46, and then I say 23. And then I'm wrong again. And then I say, I don't know, 35 or so. Yeah, you're right. So because it could be on the right part. Yeah, and my theory is broken.
No, that's fine. Yeah, but the input output in the example is input is 10 and output is 16.
Yeah.
10,
16, 7 plus 9. Yeah. Like let's say, let's just try this, and we'll see where it's wrong, because it will show me at least the first example, right, where we are wrong. It tries only on one of them. I don't know. Yeah, let's try submit. I don't know if you can see the test cases for submit. Sorry, that's how I solve the tasks. Yeah.
No, it's good.
Okay. Yeah.
No, but that's corner cases.
That was easy. Okay. Input 1, expected 0. Description. Yeah, there's even an example like this. There is only one possible number, so you can guess one. You don't have to do anything. Yeah, I mean, I can create a corner case around it.
Yeah, let's write a big switch anyway. So switch should solve it, right?
If len of wait, so let me not intend. If it's more or equal than 3. Actually, if it's more than 3, then it's like this, right? Oh my God. if n equals 1, then return 0. Yeah, that's quick writing, I'd say. If n, yeah, I'm already super ashamed. Maybe we should cut this for sure. So
Oh, that's a good exercise. Yeah, I mean, I have this
you hear what?
thought that yeah, it's indeed this weighted binary tree, and we need to understand like what is our what are the constraints of this binary tree, how we split it into basically, and I'm sure it's mathematically should be solvable, so you don't need to write any algorithm, just it's known upfront, let's say.
Yeah.
I'm also trying to figure it out now. What would be the idea?
Mm-hmm. Yeah, yeah. Okay, yeah, it was, it is, yeah, it's too stupid to work. 16, now for 28, expected 34. Okay, so yeah, at least I just don't know how to create this algorithm because what?
Yeah, I think it probably wouldn't be even very algorithmical. It's more like a mathematical solution. Mm.
Because yeah, I mean, all I can do, I can look at these numbers and try to guess.
So in binary tree, right? We know the pass we need to make, the maximum pass we need to make on to finding the right number. It's log n, right? We started with that. Then can we do some outcome of it? If we do log n and then we choose the minimum numbers from it, what would be our cost? Like
log n. You mean like integer from log n, or?
oh, actually, any like because log n is our pass, and then finding any pass of this size should be our result.
Result, yes, but not maybe the optimal one. Or
No, but the maximum. I mean, what they ask for the maximum. That it shouldn't be optimal. It should be guaranteed,
yeah.
sort of. Yeah.
Yeah, so it should be the worst. Right. Okay. Yeah, I'm still not sure what to try.
Yeah, me too.
So,
if we take only right numbers, for example, right is our maximum axiom branch. Like it has only maximum numbers on the right. So would it be in all the cases? If we look at this example on that they give, that would be 7 and 9, right? What can you scroll up?
you mean
this one.
their first example?
Yeah, 7, 9, and then we're done. So we always do. In this case, let's choose the right branch, only right branch. We do a log n minus 1, 2 steps here, and we know the structure of this tree. So we always know cost basically. And if it's gonna be other tree other than that tree, then we kind of do the same. We do log n minus 1 steps, and then we need to know the weight for these steps on the right, and we kind of should know that, I think, because we know defined number of steps. Does it make sense?
I mean, in general, yes, but I'm trying to. I don't know how to convert it in code. Kind of, yeah.
Yeah, it's not that much code in here. It's for now it's more like mathematics, I think, for us. So let's not think of a code yet. Let's think of numbers.
So when you mean what we go through log n, you mean like we try splits of log n?
Yeah. So imagine we have n, not 10 like in this, but more other number, 20, and still is our tree is gonna be the same structure as in here. On the left, we're gonna have more branches with less weights. On the right, we will have less branches with more weight. And my proposal is that on the right branch, we will have always a log n minus 1 steps to accomplish. Like in this case, it's 7 and 9. In our n is 20, it's going to be log 20 minus 1. We almost know what is going to be a cost because we know what kind of weights will be there.
But why do you think that it's log n minus 1?
Because it's from this example only. I'm looking at that. Yeah.
Okay.
Not because of that, but because actually it's a binary tree anyhow, right? We need to do a decision, and we need to find some value. We need the log n minus 1, log n, comparisons.
Log n minus 1 comparisons. Okay. So you mean that we don't need to do the last comparison because we know less or more? Right?
Yeah.
Yeah.
But actually, it's a good question you asked. Maybe it's not log minus 1. It's something else.
I'm just thinking they probably want us to do some recursion, like that in the very last step you have only the element of 2 or 3, or the subset of element of 2 or 3. I'm just thinking, so if you go like from the solution.
Yeah, I'm not sure if we need to write a strong algorithm in here. We basically maybe we can just solve it in mathematics.
Yeah, maybe it's doable. Maybe it is doable. So I don't know. So if we have 16, so this didn't work. So 13 and then 15 did not work because we can get somewhere here. I think they want us to do it recursively. No, because I don't know how you will do it the other way around. I think we somehow. I think we somehow need to know what will be the cost of solving it, having the 3 elements, and then go higher and higher and higher and higher. You know.
The tree on this example looks now weird to me. Like, is it a random defined tree, or it's balanced? Because the left branch 1 and 2, it's it's not. I don't know. It's not balanced actually, because if you go only on the left branch, 7 plus 3 plus 1, it's gonna
13.
be 11. You don't need you don't need to hear the
yeah. And that wait 7 plus 3 plus 1. Yeah, but it's not enough. You have to go for 2.
That even like that. However, I don't think you need to. You have less than 16. So is it a random tree? Here we see, it's balanced, right? It's
no. Sorry. By balanced, you mean that the sum of all the paths is equal, or?
Yeah.
I don't know. I don't know this definition. Yeah, no, it's definitely not balanced. Yes, I think it's all the paths.
So how is this defined then?
I think they just show us the final solution. So they say that, hey, let's pick this strategy. And then they explain
how this tree is constructed. It's if we construct it starting our root will be 3, for example. Then our search in case of 10, for example, would be more than 16.
Yes. That's why they showed the most optimal tree, kind of.
So it's somehow balanced.
Yeah, I'm not
It's
sure what you mean
balanced
by
by
balanced.
balance that like you need really a minimum amount to pay to find the right number with this
Yeah,
structure.
yeah.
Mhm.
Yeah, I think so. So yeah, ideally we have to think of how to build this tree without knowing the
Mhm.
end.
Mhm.
Uh, so I don't know. At any given step, we have to split somehow our array into two ones, and then after splitting, we have to be sure that this is the optimal split, right?
Mhm. So
And
your solution you're thinking of is basically to how to construct this tree, how to construct this thing. Yeah, that
yeah,
makes sense.
yeah.
Yeah,
Uh,
let's think of this approach. Actually, it's 11,
11? You
11 a.m.
mean?
Yeah.
Yeah. You're right. So yeah, I mean, honestly, I don't see myself and or us together anywhere close to the solution.
Yeah.
So yeah, I suppose I will just give up for now and probably spend the rest of my weekends trying to do this.
Well, we can continue next
But,
time with that. It's
yeah.
interesting. It's interesting how do you feel about this format?
Yeah, I mean, for me, it is fun and fine. Yeah, I'm not sure how to you people.
Yeah,
If
we're
there's
gonna see that.
anyone,
Yeah.
yeah,
Tell
maybe,
us.
yeah,
Don't
maybe,
don't be silent.
yeah, ask us questions. Maybe like in 2 years, this video will be like the most trending on YouTube. People will
Yeah,
just
it's a
find
first
this.
run anyway, so we know a little bit more than before. And yeah, I don't know. For me, for example, the idea could be the next time, um, if I would do this kind of session, not necessarily solving algorithms, but
Mhm.
doing some other task for whatever reasons.
Yeah,
Let's follow us to let's say.
yeah, that works for me totally. Yeah. Anyways, I could say it was fun for me. It still is, and thanks, Alex, for guiding and ideas and not leaving me alone with my thoughts. Yeah.
All right, all right. Well, good. Have a good weekend, everyone.
Yeah. So have a nice weekend. See you next time. Take care,
Yeah,
guys.
see you.